So 2.4 is now going to take the idea of supplementary and complementary angles and going to kick it up a notch in terms of lots of theorems that are going to be associated with the supplements and complements of those particular angles. All right, so theorem 4 says if angles are supplementary to the same angle, then they are congruent to each other. So I'm giving you instances here. So it says given angle 3 is supplementary to 4 and 5 is supplementary to 4. All right, so the long way of doing this would be this method right here, but it's completely unnecessary. What you will find is if you look at the given and then you look at the proof statement. If you look at the given, you look at those two statements, 3 is supplementary to 4, 5 is supplementary to 4. You ask yourself, what do they have in common? Well, they have this in common, angle 4. So if 3 is supplementary to 4, and 5 is supplementary to 4, and 4 is the same angle, which is where this notion comes in right here, then 3 has to be congruent to 5. If you threw numbers in there, let's say we made angle 4 60 degrees. Well, if they're supplementary, they add up to 180. So if 4 is 60, that means 3 has to be 120. If 4 is 60, that means 5 has to be 120, which just supports our conclusion that 3 and 5 have to be congruent to each other. So again, this is the long way, and this is not needed. You don't need to do this. Now, not only do we have if angles are supplementary to the same angle, but we have if angles are supplementary to congruent angles. So we can say if angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, and angle 1 is congruent to angle 4, then we would ask ourselves, okay, well, what conclusion can we draw from this? Well, if 1 is congruent to 2, and 3 is congruent to 4, but 1 is congruent to 4, then I know that angle 2, or not congruent, I'm sorry, supplementary, let's do it that way. So angle 1 is supplementary to angle 2, angle 3 is supplementary to angle 4, and angle 1 is congruent to angle 4. Well, if that's the case, then you have two angles, 2 and 3, that are supplementary to congruent angles because 1 and 4 are congruent. Therefore, 2 and 3 need to be congruent to each other. And the 6 and 7 is the same thing, it's just for complementary. So it says if angles are complementary to the same angle, then they're congruent. So if we were to say if angle A is complementary to angle B, and angle B is complementary to angle C, then we say, okay, well, what conclusion can we draw? Well, we can then say that A is congruent to C for those angles because they're complementary to the same angle, which is angle B. And for the congruent part, if angle 5, say, is complementary to angle 6, and angle 7 is complementary to angle 8, and angle 6 is congruent to angle 8. So if 5 is complementary to 6, 7 is complementary to 8, and 6 is congruent to 8, then we can make the conclusion that angle 5 is congruent to angle 7. All right, so what you see up here, again, here's another instance. So scratch this part right here because it's just not needed. So it says angle 1 is supplementary to 2, 3 is supplementary to 4, and 1 and 4 are congruent. So these are the two that are equal, which means that 2 and 3 have to be equal. And you're going to use the notion that if two angles are supplementary to congruent angles, then they are congruent to each other. And these are theorems that are going to be used in the proof. So let me show you with this next one how it actually is used in the proof. So for 2, you're given a diagram, and you're trying to prove that HFE and GFJ are congruent. So we know our first statement is whatever our given says, and our first reason is given. Well, it's a diagram. The only thing we can assume from a diagram are straight angles, and here's our straight angles. Then what I'm going to do is I'm going to say, okay, well, HFE is supplementary to HFJ. So I'm going to take these two angles and write a statement. And I'm using definition supplementary angles. But I'm going to do the same thing for these two angles right here. And again, I'm putting it in the same line only because it has the same reason associated with it. Then, if you look at these two statements right here, you say to yourself, okay, this is in common with this. So if they are both supplementary, if HFE is supplementary to GFJ, then you know that they are both congruent. And I'm going to write this out a little bit more. I'm going to say if two angles are supplementary to congruent angles, then the two angles are congruent to each other. So that's using one of our new theorems. All right, last and final one here. So KM perpendicular to MO, PO perpendicular, and KMR is congruent to POR. So we have our first statement, we have our first reason. Well, if it's perpendicular, we have a right angle. So we have that. So we can actually just write definition perpendicular. We don't have to write the whole thing out. Again, I'm skipping the one line here. We have to add this in here. We have to say that angle KMO equals 90 and angle POM equals 90. So this is line 3. And then line 3 over here is going to be definition right angle, because again, we have to get that number in there in order to be able to use complementary. Then we're going to say that KMR, this angle right here, is complementary to this one. And then vice versa on the other side, we're going to say this angle is complementary to that angle. And if you look at both of those statements, we were told from the beginning that KMR and POR are congruent. So KMR and POR are equal to each other. Therefore, we can say that these other two angles, which is our proof statement, which is the last line we write down here, are congruent because, I'm going to write this out a little bit more, if two angles are complementary to congruent angles, then they are congruent. So this might be